The topic is artificial intelligence and machine learning applications at Outlook. I'm going to invite Christian Rothenberg to come up to make the presentation. Those who wish to ask any questions, let me remind you that at the end of each presentation we have time for Q&As. You can please come up to the microphones in the aisle, state your name and organization, and also remote participants can enter their questions in the Q&A panel. Welcome, Christian. Thank you. Good morning. It is a pleasure to be with you today. Can we have the slides, please? I'm going to do quite the opposite to what Thomas said. I'm going to do everything that is totally opposite to what I said. I have two pieces of news for you. One is good and one is bad. The bad thing is that I'm a professor from the University of Campinas, so I like to speak, I like to talk, I like to teach. I have 100 slides. The good thing is that I'm a professor, so if you tell me it's a 40 minutes, then it will be 40 minutes. Ariel, don't you worry. It's going to be a 40 minutes presentation. So let me tell you about this topic, the topic of fundamentals of machine learning, and I find it very difficult to speak Spanish, as you can see. I have been in Brazil for 18 years now, and I find it difficult to speak Spanish. Nevertheless, I'm going to tell you a bit about myself. And Thomas said, don't say anything about yourself, but I have slides with brief information about me. I'm going to tell you about the research work I do. And the most interesting thing are real cases. We conduct research that have followed the entire path from the university to collaboration in the industry through to production and networks in production. So a bit about myself. I am an associate professor at the University of Campinas, not very far away, an hour and a half. My research group is called Intrigue. I am from Madrid. I have a degree in telecommunications. I have a master's degree in Germany, and my PhD studies were done at the University of Campinas. I worked at a research center for a couple of years, CPQG, and right now I am involved in a very large initiative called Smartness, and I will be telling you about that, a couple of minutes about that. A bit more about my background and the profile of the research group. This is closely linked to programmability. Alvaro referred to network programmability. We have been following those technologies for 15 years now since they came up, and we still apply these today. And even with ASICs, so SmartNICs and so on, and we have a very practical profile. So we use quite a lot of open source and open data technology. We have some contributions there for IETF too. So basically that is all about me. Smartness is a center that has been in existence for 10 years. It is a combination of the industry and the academia, the university. We have several objectives to create impact so that the future generations of students can practice their professions knowing how the industry thinks. So that is the basis of the program. We have FEPESB, which is the Engineering Research Center. This is a very solid and generous program. It has 10 years of sustainable funding. And then we have centers in many different areas in chemistry, sustainability, energy, oil, and the first is the telecom networks. The industry that supports it, and it comes from the company Ericsson, but there are other companies that are also welcome. And until the year 2032, we have a lot of things planned, all the critical areas of networks cloud computing, artificial intelligence, control plane, data plane, also security and trustworthiness, as well as sustainability. The way we work or the way we operate is a push-pull mode. And like Alvaro also referred to, there are major challenges that are open, and push from technical collaborators who are involved in the state of the art and contribute idea. We organize ourselves in work packages and produce quite a lot of research products and innovation. So, are you already tired of seeing how the networks have evolved? The message we have here is that this is becoming more and more complex. Content delivery networks, fog, cloud, edge, 5G, 4G, WAN, PAN. So all these layers are creating new innovations, connectivity, submarine connectivity, creating and redefining the possibilities, slicing. This is also a topic that I like because we were involved in not a lot of work as to do network slicing in a major project called NECOS, which is a collaboration between Brazil and Europe, and also software-defined network that is part of my DNA. And today, with artificial intelligence and the knowledge plane that we have, leads the networks to the maximum possible of automation, internet-based networking. All that is in the context of the current reality of the network world. I stole quite a number of slides from my colleagues, and I like to include the acknowledgements. This is from Pedro Casas, a colleague from Uruguay, who was one of the first persons who did the intersection between the networks and machine learning. And this internet mapping project we see on the slide is something that is very complex. Internet is the very first artifact that human beings don't fully understand, because why this is harassing the BGP and many things occur.
And when complexity goes beyond human limits, it is there that AI machines come to give us a relevant support. So that complexity is our partner today. Those mechanisms that I'm going to introduce today, it's not a class, but it's a top-level overview. And it is clear that, as is the case in all areas of knowledge and applications, all are being affected, but in a positive way. They've been upended. So in our networks area, it couldn't be otherwise. All the players and app developers, everybody is looking for have different purposes when approaching AI, to reduce cost, to the potential of new services or incomes, among other classical objectives. Now it has opened new possibilities, like generative AI. Ariel will talk about that. And there, here I'm going to focus on data that are the most basic techniques. And at the end, I'm going to try and leave some recommendations, very basic recommendations of those who are not yet using some techniques, so that they may start making progress in that regard. So I already mentioned this is a hot topic. If not, we wouldn't be here. And I thank Carlos for inviting me. And this talk is the result of a visit to Uruguay, to the University of the Republic. We have a 12-hour course that includes hands-on activities, and that is what brought me here in the end. So this is a mini class with some rationals for machine learning. And the first comment is that this is an area of knowledge that is many years old, and it in a constant revolution. And today, it's many people are everybody's using. Who doesn't use ChatGPT in the mobile, among other technologies? And it continues to grow, and we don't know how far it's going to reach. There are several factors that lead to that status quo. So, technological changes, open source, all the scientific breakthroughs. I stole this from somebody, Luciano, a colleague of Rio Grande do Sul. Why AI and machine learning for networks? There are no killer apps. There are many, many apps. And a way we can approach this would be thinking of these two possibilities. I want to detect whatever, you name it, from data in addition to my data. Today I want to predict the future based on my data. And here, put the name you wish. And at the end of my recommendations, spoiler, think of your day-to-day work, year after year, where you have a headache or a stomachache, and try and see whether you can't solve that pain with some database technique. And for that purpose, you need data. If you are establishing a connection, if you are not setting a database of your data of good quality, you're wasting your time, because historic data is going to be very important, and you need your data since day one. And there are many areas. I'm going to leave you many links and pointers if you want to go deeper into this, because in all the network areas there are many, many papers, many of them are scientific or academic, that do not apply to real world because they have limitations. Here I have a section of my talk, and I aim at limitations that prevent those techniques from becoming a reality, and I leave them there just in case you want to check that and to use as food for thought. And basically, let's see what are the areas. Security, as the colleague asked, Alvaro, that's a classic. Intrusion detection, all the abnormal behavior of your network, your users, churn, whatever, it's all a classic of where machine learning gives you a response. Traffic classification of a client, of a type of the cloud. This is cloud gaming, this is peer-to-peer, this is corporate, this is VoIP, this is YouTube. And I'm also going to show some examples. Traffic engineering, based on predicted future traffic demands, prediction of patterns, and also congestion control, this is for especially based on prediction of bottleneck bandwidth. And video streaming is a traffic that dominates the Ericsson Mobility Report. I don't know whether it's 60, 70, or 80% of the traffic that goes through each route. A router is video. Video, adaptive video, XR, VR, all those formats that need a great capacity. And what is machine learning? Well, in the end, it's an easy way to put it is having machines learn. And having them learn implies knowledge, data, experience, and basically you want to apply it where your basic technique, your human filter and rules do not apply, because there are many dimensions. The problem is very complex for our minds. These are the key tasks where machine learning solves problems that not even the best human groups can solve. And the other big area is where the dynamic changes a lot. The systems adapt, and you don't have time enough to adapt your time. So basically, there are observations that you can see in these circles. You can use clusters. My user type A and B. Probably these are users that consume a lot of broadband, or apps of one type or the other, or clusters. And also where you define classes, and you say, well, it's this type or the other, and then you have an observation, and people say, well, it's this class or the other, even if you haven't seen it before. Regression. This is a technique that helps you predict the future. You observe trends, and based on that, you predict what may happen if something changes. A classic, for instance, the traffic profile and the characteristics. Well, and rule extraction, that's more complex. And here you end up inferring chains of sequences that lead you to the future status. There are three big classes of techniques. I promise that I won't go any further in simplifying the technical things. I think that everybody will understand these are supervised techniques, supervised learning. I'm suffering trying to speak Spanish. I don't know whether you notice that. If my students see me today now in YouTube, they're going to be quite surprised. And my daughters, 5 and 10 years old, and I don't speak Spanish with them, what will they say? So what do we mean by supervised? It's that based on an observation, I can label this. I train the machine, I conduct an experiment, and I give that observation a category, a label, a class. So then the unsupervised, I enter all the data to the algorithm, and the algorithm on its own identifies the classes. And there's no need for me to give any further information, but the algorithm can identify clusters and produce projections. And here we have the autoencoders that are more modern under the LLMs. And the third one is very easy to understand, and it is characterized by reinforcement. This is a more human technique. You do something, an action, you see the results of that action, and you may have a reward. That is, a small child touches something hot, and feels the pain, and that child won't repeat that action again. So that is the strategy, taking it to computer field, to the IT field, where your environment is your network. Your decision may be picking a route over another, and you observe whether it improves your band balance, etc. So those three big classes, I'm going to give you some examples. And the pipeline, and everything starts with data. So again, if you're not collecting or storing, processing, and cleaning data of your operation environment today, tomorrow you can start collecting before you think of the problem that you're going to solve. See what data can be inputs for your problem and start storing them in a scalable manner. You need a lot of engineering there. It's not so easy. So then, with the data that you get, for instance, this is an alarm of a problem, and in that respect, I remember the first times we had talked with companies, and their system alarms didn't have the format, the class. They were not. They were in one system or another, in an Excel sheet. So there's nothing we can do there. So the machine is going to consume it, or the data will be worthless. And from there on, use cases, many. Anomaly detection, intrusion, traffic classification, mean appearance score classification. That is, you can say what kind of users are happy up to a certain level, quality of experience. And if I expand this, if I do this in my network, what will be the impact? All those analysis that can be made based on data.
Unsupervised once again, and repeating the concept, I enter the data into the algorithm, and the output produces some kind of information. And of course, then I need to have a specialist who can understand this. And I'm going to tell you about all the problems later on. I'm just describing them now. So other examples, I have all these blue dots that can be flows in a network, it can be users, it could be clients, and then the algorithm detects that there are three types of clusters: blue, green, and red. And those three clusters can mean types of applications, types of users that deserve a different type of attention because they share some features. And this has to do with the typical examples of the network. With that information, I can guide the users along one path or through a different type of path, through load balancing, through routing, through network function chains. And then you have the users with a different profile, better, or whatever, or those who are dangerous. So my processing capacity is not enough to take them across those functions. And then reinforcement learning. This is the slide that explains this. I have people who are in charge of making decisions, and they carry out some type of action in an environment. They observe the results of the action in an environment. For example, with the net flow, and I receive a new status. In my hand, the temperature has increased, and I receive a negative compensation, which is pain. And then I learn, because once again I am in a state whereby my hand is near the fire. It would not do so because I recall that the previous time I did so, well, it wasn't very good. So applying these techniques and these games, you can apply this to a game, that game with the balls that fall and you have a sliding bar, or the Mario which hops. So the different actions, you go forward, you go back, you duck, whatever. There are 6 different actions that you can do, for example. So you enter an agent of reinforcement learning to play the Mario. After playing an X number of times, 1,000, 2,000, 10,000 times, they finish the game without never again losing, because they've gone through all the different situations. It then knows when to jump, when a turtle comes, they know what fire is, they know what a hole is. It has learned everything, and you haven't taught anything to them. You just put it into the environment and you have trained it an X number of times until it has the entire intelligence, the entire knowledge, in order to play on its own. So that is a good example with those kind of games, and you can apply this to other network applications, for example, not to routing, to resource allocation. I included a virtual machine with more memory, with more resources. It improves the performance of my application. I included less. Well, it worsened, and so on. So this is used a lot. It does have its limitations, like every technique does, but it's one of the most frequently and adequate techniques to explain this. And once again, reinforcing this concept, the pipeline of machine learning. So data collection is essential. This involves several stages. And right at the core, we have the model, which is the outcome of data processing. This model is trained, it is validated and evaluated. So basically that is the core of any technique based on learning or machine learning. Now let us look at the details. You have to understand the problem. Machine learning won't solve any problem if you don't know what the problem is. So you can bring the very best machine learning specialist and put that person in your organization, but that person won't solve any problem if it is not part of the business or the domain. So that is one of the major things to bear in mind. You have to have in your team specific knowledge for that domain, as well as on the tool on machine learning. If you specialize in the domain and start entering your data in those frameworks, and today they are amazing, they are great, and they give you outputs, and you believe these outputs without even asking anything else, then you do have a problem too in that case. It's like killing a mosquito with a hammer. So there are very many techniques, very many models that could be set up. Here I include the references in this slide and more references for those who are interested in this. And these are examples such as random forest. You can see all the various possibilities. You create tree possibilities, and then you combine the results of those trees, and you can see which is the potential output for all the data input you provided. So this is a classifier. This is a random forest classifier. And I'm just speaking about these learning techniques. These are what we say the shallow learning techniques, which is not as deep, because we have a whole set of techniques in that deep learning. So these techniques even eliminate part of the need to do things manually. The specialists doing things manually, they are very powerful, but they do have problems. These are all trade-offs. Everything is a trade-off in the field, in the world of networks, but you have to know which is the poison you're drinking and what the antidote is. A couple of more examples. Now, I'm going to be speaking about several points, and I'll make just one comment per slide, 10 seconds, just so that once you see these slides offline, or if you're interested, you know that those could be problems. So a lot of data are being used, and data on their own are an issue. The volume, variety, speed, and the value depends on this. Volume, variety, velocity, and veracity, how you're going to manage all these volumes, and this does pose a challenge. Now, the problem of complexity of data, complexity, and that each network is just a snowflake. Each network is unique, so you see something in the network, but this won't directly apply to another one. There are techniques to facilitate this task, and this slide illustrates that what you learn in one region in an IXP not necessarily can be reapplied in another. There are numerous examples and reasons that explain this, and I'm sure you can all imagine this. Every network is different from another, so this will change the features. So I won't manage to do that knowledge transfer, although there are transfer learning techniques that at least give a starting point that is better. So things and models change over time. So I need to do ongoing training. I have to adapt my model. It's not just about learning and creating the best model on one day, March the 9th, 2024. Yesterday was my 10-year-old daughter's birthday, and next year I come to Sao Paulo on May the 9th, and I try to apply the same model. It won't work. Things and conditions change, and not gradually necessarily. Sometimes they change abruptly. We have a power outage like the one we had in Spain. So many things occur, so I have to always continue training the model and adapting the model. And coming back to the point that each network is a snowflake, it's not the same as in other fields of knowledge. I don't have a representative and generic data set that tells me, well, this picture is a cat, this picture is a dog, this picture is a bird. No, this is the RNP network, this is Vivo, this is Claro, and each segment has its own features. This is a network that is okay. It's working with links at 90% usage, which is what they want, and the other one, when it's at 30%, it's not well, because there are intrinsic characteristics. Whether a network is operating well or badly is not something generic. It's not uniform and applicable to all the different networks. I need to trust and interpret the results. I'm going to have attackers, and I'm aware that data are used for learning. Someone is going to enter data and have good examples too. So automating 100% is very difficult, but major progress has been made. So the complexity of the model, the more complex, the better performance is delivered. So what is the trade-off? That I cannot explain why it made certain decisions. If I look at a decision tree or a linear regression, I see a point above or below the line. If I put it into a deep neural network, I don't see all the statuses of the neurons. And why did it draw that conclusion that that user has to be blocked? So this is essential for any operating environment. So now let's have a look at some cases. If you want to know more about these, there are major surveys out there with very many examples in many different fields. This is from the year 2023. Classification, streaming, and this is a classical one of 2018. Traffic routing, failures. This is a survey type paper with references if you wish to delve deeper into this field. Then this is a mandatory reading, and you will find these tables with the references. And of course, many of these are not applicable to real life examples or cases. Over here, you have the type of data that were used, synthetic data or data that were really captured from real networks. And this could also be more or less interest to you. Let us now dedicate 10 minutes to a couple of publications, real life use cases from my research team on intrigue and on smartness. There are two. One is YouTube and 4G and 5G networks, and then optical networks using the concept of network digital twins. And this is quite a strong, what a powerful concept, and I'm sure that this will be with us for a long time. It's applied to all the areas of network of engineering, and network engineering wouldn't be an exception. In this paper, and this was done a couple of years ago when we started with the first 5G networks, we started to think about how this would affect services, and interesting services. And you have this rabbit that seeks to adapt to the network conditions. So the quality of the video changes depending on whether the network is congested or not. So this is quite a challenge. What we basically did was to see whether that traffic is encrypted. We can only see this when we look at the patterns of the packets.
And using a metric based on those packets, we managed to correlate that user and that traffic use was having whether the experience was good or not. So we did all that work under a controlled environment with real tracers. I went to a 4G, 5G network, and I saw how the channels varied and the flows that I could get, and the latency measurement. So it's a controlled environment. And in that controlled environment, I implement all my techniques to see which one gives me a good correlation. I use features. So this is the mathematical part, to reach those features that provide me the information I need with a good performance. So, and I managed to see and to estimate whether the quality of experience and if it will go up or down, whether there are going to be many quality shifts. So all those things can be seen using those techniques that I just discussed. So rotor tracers, I execute with 4G, 5G, I alter the conditions, and I develop the technique, but I'm in an emulated environment. It's a lab environment. Is it realistic? Well, sort of. And YouTube does it in one way, and Netflix in another. Everybody does it his own way. So everything is secret, and that's a differential, and to see which adapts better. So those are things that we also investigate. And I was not happy, so I sent the students to the streets. Well, no, I didn't. It's not that I kicked them, but I encouraged them to go with the mobiles to walk, to go to take their bus, their trains, and to see on YouTube and to collect real data. 5G standard, no, not standalone. It's when the rollout of 5G was just beginning. So imagine you go here through Paulista, you have 4G, then 5G. And this is what we did for some time. It was a good time with a smartphone, an Android smartphone, with the apps and the proper software. You can capture those logs of the level of the network, of the channel, signal strength, and so everything that 5G offers you. It's data, new data, GPS position. We can correlate that with public data. And then the experience logs to YouTube, install, etc. And all with data. There you can draw things, you can predict things, classifiers, and you can watch things that we can observe and that we have observed that were expected to. If you move a lot, then you go from 4G to 5G, you change the network and the app doesn't like it. And you have those and it will stop. And we managed to predict in 7 seconds that would happen. So if I know that the video will stop in 5 seconds, I may put an ad that I kept until the network is recovered. But that implies having information between the different layers, between the YouTube app and the operator, that don't talk to each other necessarily. I have 4 minutes left. So now let me tell you about the last real case. And this is absolutely real in the sense that it completed the virtuous cycle that any professor or researcher imagines and wishes to have high impact information, research. You can publish the best lectures in the world. You train PhDs in a relevant area. You have corporate funding. You have a company that will pay you for doing that job. They give you access to real data and of the real customers. You generate patents, and then you see that method goes to the product. So maybe some of the networks that used by that vendor have that technology. They're offering it activated, and in their core they have the concept of the net digital twin. It's many areas in the optic that machine learning is a wonderful tool. I'm going to skip these all. I'll leave it here. You'll have it available in the PowerPoint. Well, planning versus transmission, there are many. To focus on the concept of the network digital twin. A digital twin, it's hard for me to say it in Spanish. A digital twin, gemelo digital. My father was a twin. He had a twin brother. So digital twin. It's used in many engineering areas. So you have a digital representation that is and you want a digital representation of your physical object that really represents what's happening in the network. And it's a concept that when we started did not exist. We called it a network mirror. But then up to even IETF has working groups in the network managing group. They're working that because they need standardization and they need phases. It's an interesting area. There are lectures, there are many papers, and this is the concept of the physical network, the transponders, routers, amplifiers. We capture telemetry, circuits. We use techniques of artificial neuronal networks to represent that network digitally, and from that digital twin, I can develop apps for quality transmission that will enable me to predict things. And the one that we explore the most is one that gives you that can help you locate soft failures. The failure has not happened yet, but our telemetry, our AI, is telling us that an amplifier is close to fail, is about to fail. So I'm not speaking of hard failures, that the truck will go by and cut your fiber. No, it's not that sort of thing. These are soft failures. But it's interesting because you can take your engineer proactively to replace a piece of the equipment before it fails. So, well, I'm running out of time. So, data, AI, real setup, tested at the lab, and with data fine-tuning of an operator, the client that had the machines on the field. We considered that our model was corrected. Very, very happy stories. It was not real time that our technology was in the field, but we succeeded, and we managed to see that when 3 months afterwards, after receiving the data, we asked whether there was an amplifier. We were confirmed that, as a matter of fact, they should have gone and changed it. Those techniques are so interesting that even if the amplifier does not send you the telemetry, you don't know how it's working, and all the neighbors will accuse you, and he says, that guy is not working well, that router is not working well, take it somewhere else, but because you can't trust the data, the telemetry data provided, but you can trust your observations. And with this, basically, well, I have more use cases. I'll leave this if you want to identify cloud gaming in or ESAP. We have new techniques. These are reports. That's my last slide. Conclusions. Here I recover the image of detection and prediction. Machine learning is here. I can't ignore it. Generative AI also. Machine learning is more basic, and you need data. That very famous data is the new oil. Well, and they have to be refined. The data have to be refined. Recommendations: start gathering data that you think that might be of use in the future. Portuguese is winning. I'm running out of my Spanish. I'm tired. So think of where it aches. Do you have a headache? And start attacking it. And how do you attack it? Well, if you don't have the local expertise, then try to find a partner, research groups, call the universities, the students. Even if they are they're beginners, they know the techniques, and all the people in the academia, we love real data. We know that you have to be careful, but I'm sure that you're surrounded by people who know the techniques and would really benefit of your real data. And try to innovate, risk it a bit, and at least try to have a proof of concept. So thank you. And there I'll let I leave you with the contact. It's a pleasure. Thank you. Roberto Villablanco. Thank you for the presentation. That was very, very interesting. All the use cases have an application. And obviously, you mentioned an absolute truth, and that is that AI is here to stay. It's not like in the 80 something where there was a brief wave, but then died down. And now, of course, the situation is completely different. But unfortunately, in today's world, there is a lack of connection between the technical part or human curiosity and what makes the world move around, that it's not human relations but money. Those apps, that app in my town, they would call it a killing application. It has not been invited. It's a curiosity, but in the last nano, OAL presented use cases, and it was very disappointing in my because his use cases were just too basic. That is, having a very good reliability to see whether it's going to rain in 15 minutes or not, and then the San Francisco and the cities that maybe you're in a taxi, and we haven't found, in my view, the union between technology and the business that may make it remain in time. Well, thank you. Well, I think that we mentioned this. There's no such thing as a killer app. Each of us have to look for it. Where's your toothache? And maybe it's just that, just knowing weather, because you know that weather will have an impact on your work, and you lose money, and people will lose money too, your customers. That's enough. But the other day we were discussing things with small ISPs, and I'd like to know whether that new client that comes already has a traffic profile just the same as all the others that I know that will abandon me in 3 months, taking my machines home, and I lose them. And if they don't stay for 6 months or 12, well, it's money I lose. So, and maybe with very simple patterns, as you said, I can solve this. I don't want, because, or I can say, well, I go and I'll cure myself from it. So there are many killer apps, not a single one, and I don't think it can be replicable. And I always say that Google is both good and bad example because it shows you the way, but Google has unique conditions, data engineering, knowledge that do not apply to anyone. So it's like, well, they build their own routers. They absolutely master the entire software, and that's something very few people can do.
They show you the path, but okay, thank you. Ariel, don't count this time. I'm past 8 minutes. Carlos too. Carlos will send me a WhatsApp and get mad at me. Hi, good morning. I'm Oscar Gonzalez. I work in the multidisciplinary group IoT. This is a multidisciplinary group on Internet of Things and cybersecurity in Latin America. I have a specific question. I realize that many of these learning models that we are seeing require large data volumes. How can you guarantee privacy of users during the training, particularly in the distributed models in real time? What role do you think the federated models and techniques could play in view of this challenge? Great. The question already includes part of the answer, federated learning. I don't send you my data, but I learn locally and I send you my model. When I send you my model, I'm not directly giving you the data of my users. So that has to do with privacy. And that is one of the techniques, IoT and probes and all the rest. are exploring this widely. The other major technique has to do with generative AI, with data documentation, that has to do with a relatively small set of real observations. I create synthetic versions that are very much alike. So I create large data volumes and I combine synthetic and real data. So these more advanced deep learning techniques that need large data volumes, they don't work with small volumes, then I enter both synthetic and real data. So there are significant progress that has been made to take care of the privacy issue and also the skills and performance, the capacity. Do you think that we could be speaking, for example, with the polymorphic encryptor, where we see is a trend of using all these mathematical algorithms to improve security and privacy in challenges such as these? Can you holomorphic encryption or computing? This is the data are encrypted and I can do reading through. Everything has been encrypted today end to end. Not even within the network I managed to see the content of the applications. And to manipulate data from others in a secure way, this is a good technique too. Thank you. Thank you. Good morning. I'm from the Getúlio Vargas Foundation. I'd like to ask a question in Portuguese, if you don't mind. And you are from Unicamp. You shared with us that part of the training process for machine learning involves a specialist for the pre-data processing. So this is how the model shall learn. What I would like to know, with the progress made in AI, to what extent AI will be able to do that task, that AI itself can pre-process the data and understand which is the best way to model machine learning, and this would be with a simple prompt, or there's a theoretical limit? Excellent question. I have a slide where I show shallow learning and deep learning and the machine. So the more we go towards these techniques, human beings disappear more and more. But this will largely depend on the use of those results. If the problem of the output is not 100%, and I didn't manage when I'm going to explain this, there's no issue. But if I decide to cancel that SLA and I'm going to send traffic that is going to generate some kind of problem, trusting this 100%, well, I have to answer with another question. Do you trust ChatGPT answers 100%, or Gemini? Would you copy and paste your answer in a test just blindly? This will largely depend on those tests. So this will also depend on whether this will have consequences or a legal impact, or if I have a bias when processing this due to actions that were taken by a machine. So there, humans will try to validate somehow, and specialists don't disappear. The network specialists won't disappear. So the presentation is more in that direction, to be more effective, to be more productive. So this is a tool. Now, if I have a hammer and you have a borer, then the responsibility ends up being yours. Thank you. Thank you very much, Christian. we will now go on with the session. I'll give the floor to Ariel Weher, who has specialized in networks and systems, and he will make the first part of the presentation on generative AI for network applications. Ariel, welcome.
Bueno.
Hi, good morning or good afternoon. Let's wait for the presentation. My presentation doesn't have the level of Christian's presentation. I don't know whether you're expecting something like that, but my presentation has to do with the use of artificial intelligence and how we put it at the service of the AI ops. We're going to do this together with Carlos Martinez, who should be online following what we are saying right now. Charlie, are you there? I guess he's somewhere. I'm not going to waste any time. So I asked AI if they wanted to come and make the presentation. They said no. They were afraid that they would be asked what computing was or graphics. So please don't ask me that, because I will be in a serious situation. So what do I expect to do with this presentation? So we proposed trying to solve common problems we come across as operators with issues that we can have access to without the need to be Google. We heard about all the advantages that Google has, but with the tools that we can access, which are mostly open source tools, with the hardware we have available today, and with the operational systems that we have and the tools we have at hand's reach. So what can we do to automate the tasks that we face on a daily basis? As we heard just now, let us try to make this the Swiss penknife of networking. AI told us that the first part of the presentation is the most important part because it generates impact. This here is one of the things that we managed to do in a very short period of time. It's a bit strange, but let me explain this. This is a Telegram chat. This is a large language model. It's Claude. It's one of the competitors of ChatGPT, and this is connected to the database of an NMS and to various network entities in a production network. And who hasn't come across in daily operations that someone comes and said, I noticed something strange happening in the network? What is happening? Is there an issue? It might be a client, it might be a manager. So someone comes and asks you, there's something happening here. What's wrong? And you have alerts, you have NMS, you have a large number of knocks around there, and you don't have an answer normally. So what we did in quite a brief period of time, we took this from 0. It took about 2 weeks, about 3 maybe. So we sent this through a Telegram bot to make it easier to present. So you will see here on the right that you have a prompt. On the left, give me all the active alerts that might be generating claims from clients, and the model connected to a large number of information sources and went out to identify the potential problems or the potential things that could be not according to the standard and could be leading to claims from clients. And this is what it found. It found a UPS with an issue, devices that were restarted, in the last day, and this is something I did 2 nights ago while we were having dinner this week, and it found high latency in one of the clients, and it gave me the customer name, the name and the IP address that was assigned to that client. And this was done using open source tools and in a very short time. And on the other side, you have the same system. We told the system, all right, tell me all the BGP sessions that are in established state, but don't give me the IPs, just give me all the information of the IP sessions and give these in a TOML format. And this is the information it produced from the routers, the administrative status, how many seconds it was connected, the ASNs, and so on. So this was the purpose. Charlie will share with you a couple of us of what we tried to do with this presentation. I'll go on. So we don't need, it's no point in saying today we are aware that AI is changing the world. It's not about learning Python, it's not about learning how to configure a device, but to generate the necessary ideas in order to reach the documentation and ask AI to help us interconnect all the tools in the best way possible, and beware, in the best way, in the most secure way to make these things happen. I won't waste time on this, but basically we are aware that there are 3 things, and this is something very important. In the past, you had to read a book. At least I started reading Halavi's books, and then Ivan, and then RFCs and the meetings. It was about understanding a topic. It wasn't so easy to understand the topic. There were a lot of things that you had to learn in order to be savvy on a given topic. And then we had the browsers. All of a sudden, we had the browsers. And I'm speaking about Alta Vista and things we had in the past. But that was the Google era that led to the fact that if I need something, I enter the browser and see if someone else came across the same problem. And I find a little recipe that I can apply to my environment, which will now allow me to make daily operations in a simpler way. Today, we are in the era of language models. And there is a group of young people. We have a group of young people who doesn't even consider using the browsers. They ask everything to the models. And in fact, this week I heard about cases, they told me about cases when ChatGPT doesn't work, the operation of certain things stops. It's as if the idea of going out and finding options wouldn't exist. So what we have to do somehow is to understand, like Christian said a while ago, that the information we obtain from such models can, and in fact is not exactly, the idea is to understand some of the concepts. I won't go into the details. We already heard a lot of information about this, but basically generative language stems from a large data volume that is parsed. We're going to see how every model will operate. It's going to take a large volume of data. It will format that data and make it go through what we call a learning process. It's going to parse that information and then transform it into vectors. I'll give you an example later on, and will then give it a certain representativity so that it can be transformed into certain types of calculations. All this will be non-deterministic.
So this means that when you ask these tools the same thing twice, the 2 times it will give you different answers. And be very careful with this, because very often the questions that you ask, especially if we consider that we are operating in critical infrastructure networks, I cannot come and copy and paste what I'm told by the language model and apply it directly in the machines that are in production. And it seems stupid. I shouldn't be having to explain it here, but it happens too often. So, what happens with all this? The information, the corpus, that is all of the information, ChatGPT or any other model, turn it into a token. If you scan this QR, you'll see that an ORL opens with a brief exercise, a Python code where you write any text in a form, and that gets tokened. That is, it will transform just as you see here on the screen, and you'll receive different models of tokenizers. As any text, it will divide into the more elementary parts. Or as it says here, a token is basically a little piece of information that turns into a multidimensional vector that makes it possible to conduct mathematical operations later, to look for similarities so that the models may somehow put together what they're going to generate. I won't discuss this in detail because it's not to the point. But as you see here, there's a text that you pass. And why am I explaining it? Because you just had a bright experience. Because the models are charging you per token. When you use these tools, you are going to be charged a certain number of cents for each of those tokens that you have there. And that considers the tokens that you send when you write the prompt and the tokens that the model gives you back every time it answers. So what happens if I use the language model of a third party, for instance ChatGPT? I'm going to spend money on the basis of the number of tokens I use. If I run my own model, because I have enough hardware and I may run my own model in my computer, I don't pay it, but I don't know whether my model has the same quality as the others. What is a context window? Well, this is a very important thing. When you speak, I'm sure that you've used language models. You give them text and the conversations are very, very long. And the truth is that the model has a certain capacity to retain the conversation, and depending on the model, there's a certain number of tokens that it can handle. Then comes the graph that tells you how many. But if the conversation is too long, then it's too complicated to keep it. So the longer the context window, the larger, so much the better will the conversation be and the response that the language model will have. And what will happen is that if you go too long, then the model may request you to start a new conversation, or else it will get that long conversation and try to summarize it. And in that summarized conversation, it may make errors or ignore certain information. But let's assume that I put the configuration of a router with tens of thousands of lines, and if that configuration is much greater in the number of tokens than the context window, it may happen that certain lines lines are ignored, and the response will be just anything. So be careful if you want. This is a parameter that you'll have to consider. And the same if I process logs or things that are very long. Here, there's data of the context windows in each model. Today, as a matter of fact, this was taken some days. Gen AI gets some tokens. This is GPT-1. There's information of each. The information is available in the agenda of this event. And the models that support more windows are the ones that will charge you more when you use them, of course. Limitations. The corpus. So as I told you, whenever you train a model, you introduce a very significant number of billions and billions of data, and that causes the model to be sort of arrested in time. So these are the official data. There you have the URL where I took it from. And for instance, OpenAI has this cut data when they quit taking data and they standardize them. OpenAI October 2023, Google January 2025. Google may be one of the models that are more promising. It's Google, right? And there's a pair of models that are quite interesting, especially X. No, we don't have information. But notice that most of 2023 or 24, if you ask them what day is today, they'll probably tell you that it's 2023. This is the worst thing that can happen, hallucinations. What happens? A model learns things and then responds based on that learning. Do all models hallucinate? Yes, because they are arrested in time and they don't know of the new things that happened after the cutting date. A model learns, for instance, what a volcanic eruption is. What happens in an eruption? Well, you have the plume, then the lava, and horrible things happen. Okay, so if you tell it, what volcanic eruption was there in 1980, it will give you the details. Now, if you ask 2025, it doesn't know because the cutting date, for instance, was 2023. However, it won't tell you, I don't know. For the model to tell you, I don't know, specifically, you must tell it that when it doesn't know something, it should tell you that it doesn't know, because if not, it will hallucinate. And as the model knows what a volcanic eruption is, he might even invent a date and will say, that such and such a day in 2025, and it will even invent, it will make it all up, such volcano that doesn't exist, and this is possible. Why does it happen? Well, because of the cut date and because of bias in training. If when you take the corpus, you remove some data, you're leaving spaces that the model can complete as the way it considers it necessary. So, for instance, here there's one that I got. And I say, in Proxmox, how do I configure VPN? And it knows what VPN is, it knows what Proxmox is, but the feature of Proxmox appeared much later than its cutting date. So it said, well, 6.0 or later, go to the tab this or that, and wrote a manual, but that doesn't even exist. He wouldn't admit that he didn't know. And the next one, I was configuring a lab with a container lab for a simulation, and I told it, well, here I'll tell you all the machines that we have to connect. I gave the links and I said, give me the IP addresses. And if you look at the left, as I told him almost everything, it started giving me IPs, and some of them are invalid. Ethernet 1.5, those are Nokia. machines, 192.1.324.3/24. It generated and just gave me anything. And on top, a company, a very important company that sells AI products, has tier 1 support by AI. And there was a failure in the product, and when the clients went there to claim, the AI support said that it was natural, that it was a corporate policy for the product not to work. And this was published in the newspapers. Down there, well, at the bottom, I left the forms because a lawyer presented in a trial false data. The guy in the document requested data, jurisprudence, because he was filing a claim against Avianca and asked jurisprudence of people who had won trials. And ChatGPT just made them all up and invented airlines and people. And the guy went and took it to court. So hallucination, and he didn't check it, so he had problems. Another problem that we can have is the lost in the middle effect. When you have a very long conversation, but you're still inside the context window, this is something that happens. The in the middle is sort of ignored. And please consider this when you are asking too much of the models. The beginning and the end are sort of always considered, but the things in the middle are sort of neglected. No more presentation.
Se van a preguntar, ¿cómo hice lo de...?
You may wonder, how did I ask what's not working in the network? Well, Engineer Martinez, if he's here, will tell you about it. Continuing with this presentation. Yes, let's go on where Ariel finished. Carlos?
Carlos, gerente de tecnología del ACNIC, quien nos acompaña de forma remota.
Gracias, Elisa. Bueno, yo voy a continuar
I will pick up from where Ariel left. I hope you can see my presentation. This presentation will be available to all. It contains much more material than what I'm going to share with you, and some of the things overlap, but others are different to what Ariel shared with us. And I'd like to start where we left regarding the limitations of the language models. The language models, we mustn't lose sight of the fact that they are major text processors. But no matter if they can deceive us, it's not that they think, but what they do somehow is trying to predict the next tokens based on the prompt that I enter. You must have heard a lot of things, terms such as one-use terms, multimodal terms, single mode models, and something recent is the deep research models that do deep research precisely than the intelligent agents. So this is changing so rapidly that I wonder if I could answer any questions on some of these things. As Ariel was saying, the issue of the context advantages and windows changes all the time. These presentations that we're making today might become obsolete in 2 weeks, 3 time. So to unify the terminology, the single mode models are the LLMs in its more basic format. like GPT-5 back in November 2022, so it seems like a life ago, but it was less than 3 years ago. And these were like the token predictor in its pure form. Then the multi-mode models also use tokens, also predict text, but can also generate images. And somehow these are also capable of understanding to a certain extent. They have more limitations, but they are capable of understanding images. The reasoning models, this is something that is quite recent. I think it's less than a year old. This is like an additional turn to the LLMs, trying to minimize the issue of hallucinations that Ariel was referring to. And the model somehow tries to self-correct. They implement a mechanism called the chain of thought. And if you go to the interface of some of these models, particularly ChatGPT, DeepSeek does the same thing. It shows you what the chain of thought is. And you'll see that the model prompts itself somehow, trying to avoid the problem of some of these hallucinations. It takes some time. It's amazing how it takes some time. The models that do reasoning take 30, 40, 50 seconds, a minute and a half to answer sometimes. But in general, the result is better in terms of quality. The models that do deep research have the great advantage that the way in which they show that they're not hallucinating is that they can aim at the references. So when they affirm something, they're going to include a link to a document or a website where it's supposed that you can go and verify the validity of the reply you receive or the information you receive. How to use an LLM? I think I'm not saying anything new. You have all used ChatGPT or some of these models where you have an interface, you interact with the model, chatting somehow. And in fact, the chat layer is a layer that has been there before, prior to the model. The chat layer is not irrelevant because it introduces the concept of memory. The LLM has no memory. Whenever we asked something, it's going to answer something without any previous notion of previous conversations. The illusion, the concept of memory is something that the chat creates. And this is an important notion because when we use the API of the model directly, for example, what Ariel was doing and what I'll be showing you in a while, there is no chat layer and there's no memory. So we are the ones in charge of generating the illusion of memory in the sense that we need it. And when you have an application, you're going to generate applicability. The fact that it has no memory is positive. If you're starting from a known initial step is better. So we have the concept of prompt and we have the reply. And this is where we start to extract what we need from the language model. I won't dwell too much on this slide because you all know this. Each prompt is in itself a state, a fresh state. The illusion of memory is created by the chat. These are some notions of what makes a good prompt. I'm also leaving a couple of ideas regarding how to write a good prompt. They're not perfect answers. Ariel said you give the same prompt twice to one of these models and the answer will be different each time. It's like when you speak with me or with a human being. You ask me 2 times the same thing and I will not answer the same thing every time. Always bear in mind the issue of the limitation of the context window. If you have very, very long conversations, it's not that it's not going to say that it has no more context, but it remains without context and will start to summarize this or will start to forget. So when I started to use this for software development, it happened very often to me, in fact. A brief overview of the available tools. I distinguish here between the LLMs that are based on the cloud and others that you can run locally. Let me make a couple of comments regarding the pros and cons for each. These are the most common one: OpenAI, ChatGPT. You're all familiar with this. We also have Claude. I like that a lot. Mistral. I'm very fond of that too. It's one of the ones I used initially. And the recent one that was incorporated was in the headlines is DeepSeek. The LLMs that you can access through the cloud had the advantage that are much bigger. They have many more parameters. Now, this issue of the parameters we didn't mention initially, but this is like a neural network in which each artificial neuron has numbered parameters, and these parameters are like those numbers. The model is, in fact, a file that represents two things. That's a model. It represents parameters, a large number of numbers, and how these neurons connect with one another. It's no trivial structure. So the more the parameters, the better, the higher the capacity to understand the things of the model. The models can be regulated in terms of their size. So you can have models that are the same that you can access through a cloud, but you can run these locally. These are tools like Ollama or LM Studios, and Mistral, for example, is cloud-based and also can be used locally. But the difference is in the amount of parameters, so the amount of answers depends on the number of parameters. If you want to have a recipe that works more or less, models are measured in billions of parameters. In general, you'll need twice as much RAM than regarding the number of parameters. If you want to have a 7B model, 7 billion parameters, at least you need 16 giga RAMs. I have 16 giga RAM in my computer. It doesn't work with my computer because it makes it run very, very slow. The quality is not the same, but it has a great advantage that you can work locally, so I don't have the concerns that I might have in the case of a cloud, which is privacy and so on. So you have to see what is best for each of the cases. These are the URLs of the LM Studio and Ollama. If you Google it, you find it right away. And it's quite interesting to try these things out locally. But I wanted to get to this point. LLMs as such, as Ariel described, which are trained with all the text that they can find in the internet to build that corpus, of the text corpus, these are generalists. That is the person who has a lot of general knowledge, who knows a lot of many things, but they don't have knowledge about very specific things. I can ask them to criticize the Divine Comedy of Dante, but if I ask it what router in my network has issues, it won't know because it doesn't know what it is. It has no information at all. It's not information that is out there in the internet. It was never part of the training corpus. You might ask yourselves, well, there might be some way to overcome this. It would be great if I could use the LLM to solve my own problems. And in fact, that does exist, and these techniques can be divided into three basically, which are what would be the prompt engineering, and to provide additional information or additional context as part of the prompt, what we call the RAG, the Retrieval Augmented Generation. And one of the things that I didn't even include because it's not available to mortals, which is fine-tuning of the model with specific data. The prompt engineering is quite trivial. The concept is quite trivial. I take specific information on my problem.
For instance, in the case that I was showing, part of the context information that I have to put there is the configuration of the IP addresses that the model can access to see something. Then I'm going to look for that interaction. Things, for instance, as the log files, or I can put all that as part of the prompt and ask it to reason. And when I put together a big prompt like this, I'm giving it more tokens and it's reasoning. So that is now what is the big problem of that is that each question is huge and I have to give a lot of context, and I am limited because of the window of the context. I can't give too much information because I exhaust the context windows and the answers are worse. So to solve this, I have this RAG mechanism. If you ask me questions, I haven't implemented, but the truth is that there are tools for all the components there, and all the open source. There are also paid things, but everything can be done with open source. In the end, the RAG works with the concept of pre-processing the questions that the model is asked, tokenize them before sending them, and create a database with a specific format already tokenized. Remember that the models reason through tokens and not complete words. And when indeed you're asking the model things, you said the question already tokened with the context that is relevant, and that is here is where we are saving window context. That database, what it does is to enable me not to take all my context or every time, but the one that is relevant just for the question that I'm asking. And the third thing is to pass metadata, where I'm going to be able to put things like the references. Do you remember what I said just a few minutes ago about deep research models that give reference? Well, giving reference is important. Just as in a paper you include references, it's a good way you can know that the model is not lying, not hallucinating, but that it's doing on the basis of references. So this is quite greater than putting everything in the prompt, but the results are better. I repeat that this is the good thing for all these components there, from the DLL or the Victor DB or the retrieval layer. For all that, there are open source tools, and you need to put together the pipeline that each needs. So now let me go to the end, and I'm going to show you some use cases that are based on an idea that I had some time ago that has to do with the digital twins that Christian mentioned a while ago. So I called this introspection, network introspection, and what you're going to see now is LACNIC network. Autonomous System 28,000 analyzed and simulated, bringing a language model. So a common problem is that when time goes by, the configurations get disordered, and that's always happened in all the networks. There are comments in the access list saying do not touch Carlos August 2024, and just that. So after 10 years, and those configurations, you only change the router, but the configurations migrate, and you feel sort of funny changing it because you don't know if you're tweaking things. It seems as if you weren't doing anything, but you're not too sure. And the roadmaps, I would even say that it's worse, because if the roadmaps are not applied, they won't do anything. They're just there. but you feel sort of afraid of removing it because you don't know when you'll need it. Something that makes me very anxious is naming the road maps. If you have the ACLs, if you have can announce only certain networks, the roadmap is called different in the three routers, and that makes me feel physically bad. And of course, so as the router configurations are text, and this is not a trivial thing, remember that LLMs are text. Can we do anything with that? Well, and the answer is yes. Actually, you can do many things. So this is sort of the analysis that I'm doing. So I say, well, out of time, issues, and because the complexity is too big, I didn't do this for all the network, but only for our backbone. So I downloaded the configurations of the 4 teams that are important for that. So 4 routers of a well-known vendor. And I thought the following. Well, first of all, I'm going to download the configurations and I'm going to upload it to the 4.0, the ChatGPT model. We don't have any sponsor agreements, but we don't oppose. If somebody from PNA wants to come and sponsor this event, we're happy about it. And the idea was basically 2 things. First of all, to ask if to analyze things and to see what's coming. And the second thing is, I said, help me mimic this network using a well-known tool as the Container Club. If you don't know it, please study Container Lab because it's a wonderful tool. Then what do I have to do? First of all, I need to give the context to the model. I need to tell it, well, these are the configurations of my machines. I download them as I'm going to use the model in the cloud. And this is something that I have to do not just with configuration, but any other data. You have to sanitize it. That is, although they say that in paid accounts they won't use your data for training. They the only thing, just upload only what you want to analyze. So there's a command that is very good with this vendor, that is ShowTech, that already does that. You do a ShowTech to the routers and to generate a huge file, and in one part it has the sanitized configuration. Why? Because the idea is that that command is what you send the technical support, and you don't want to send the passwords and the TH keys to technical support. And if not, you can do it manually, of course, or you could even ask the LLMs to build a script to do it. Once you Well, let me quit my presentation form to show it. It's seen more or less like this. Here I have, what I did was to create a project, and I uploaded 4 configuration files. I could have generated more things, but I kept it easy, and then I started asking questions like this. Where is it? I asked things like, tell me what the different roadmaps do. So the analysis is very good. As a matter of fact, it realizes that they have different names, but they do the same, so I felt identified with my LLM. And I asked different things. There's another chat that's very good, where I asked a question that is as follows. One of the things that we do in Montevideo is we have a couple of copies. We have a copy of root server K and E. So I asked, what would happen, what should I do if my root K copy has connectivity problems? So it gave me a number of things that are very good, because actually it told me the roadmaps I have to identify in each router. It told me the paths that announce that router and which do not. And in the end, this, as it is, it's excellent documentation. And as a matter of fact, it is something that we hadn't written it like this. This is information in your head. If you have any problems with this, I think what I have to do, I would pretty much do this. I would never write it, and I would never document it. And so for me, this was already value. So then let me go back to the slides. The next thing I asked it to do a sketch of the network. As humans, sometimes we feel it difficult to update it. When I'm saying of a sketch, I ask you to be careful about this. The LLMs know how to draw. If, for instance, you ask a picture of the Pope with a glass of Coke, it will do it. But I don't want that. I want a diagram. But because if you do it as an image, they'll do just anything. But there's a secret for that, using tools like Mermaid or GraphViz, where you can represent the diagram as a sort of a programming language, where you can express the diagram as a sort of software, more or less. And usually I do better with GraphViz than with the other, because Mermaid is good and it's not good for networks. Mermaid is the result is nicer, but so this was the product in GraphViz of that diagram, and it's very good. Believe me that our network is indeed seen like this. This yellow globe that says internet is because I asked it, because somehow I need to model it, and I said, well, the ASs that are in the network are there. It's those two. Now do something that is called internet and may connect with those. What else? The issue of the digital twins. Here I asked her to generate a container lab to emulate the network. Then afterwards I'm going to introduce a sanitized version to make it available, rather than a digital twin that I called it a digital half-sister because it has only one of the paths, a full digital twin that goes both ways. It reads the status of the physics and emulates it digitally, but it can also make changes in the digital, and that gets reflected in physics. But this one, it's not like that, only one way. Now the issue is that if I wanted, let's see, it's here. This is the result of the emulated network, and it's also very good. If I wanted to, for instance, to change something in the network, I can mimic it here and see what's happened. If I wanted to a copy of a server, or I decided that I'm going to migrate from one of these models from a known manufacturer 1 to 2, I can say generate this in this other format so that the same roadmaps are respected. As a matter of fact, here you have it. It generated the configurations of the machines and a sort of tabs for ASs that are not our own. And I even have the same IP addresses, so when I do the routes and the reverse of DNS, it's real. So it's a very good simulation. And as I'm running out of time, I briefly wanted to go to the last case that I had done that has to do with this function calling. I mentioned it quickly. There's a concept that is function calling in in cloud, it's called differently. And the people of Anthropic are generating a protocol that is called MSP that they want to standardize to do this action. That is, tell the model not just that it has this concept, but it has some tools available for some things. So, what I said was, well, let's try and develop a tool that may enable me to diagnose simple connectivity problems. A classic, for instance, a classical call is, I can't reach this IP address, ping. So what I do is to build, and this is done through the API. Remember that we said that when you do the API, the model has no memory, so I have to repeat the entire prompt. What I do is basically three things. One is I program a function. I did it in Python that is for it to do a ping. Well, actually, I asked ChatGPT to do it. I had to change it a bit, but it did it quite well. And then I asked, here, look at this. Let me see whether I can use this. Here I'm telling it I form a system message, and it's like a fixed prompt. And I said, well, do network troubleshooting. You have these tools available. And here, let me see if I can do it in some other color. And here I'm telling it, I give the functions, the roles, and I tell it what it does, and the parameters, and the output. And then what we do is a tool that I ask, well, I have problems for connecting to this IP address, and after a while it will return me things like this. Here it went ping from the 3 routers, and it says, well, I managed to do it, but I found some packet loss. I recommend doing this or that. And here there are several interesting things that I'm skipping. I only told him that I was having problems and I have a ping, and they didn't say where from, nor how many pings I had to do, not even to look for packet loss. I said there were problems. And on his own, he realized that there were packet loss. And an interesting, I didn't have to look for a parser for the exit. He could read it as it comes from Linux, and to interpret what happened. Because all that is basically text. And the LLM probably was trained with 1 million pings that are available in the internet. So I'll leave you with this. I'm sorry I went rather fast, and I leave you with a brilliant example of AI this morning. I don't know whether those birds are called cardinals. Well, but they asked it to make a picture of these a model of AI. Give me an image of the cardinals in the conclave in the Sixtine Chapel. I wanted to thank Christian for sharing this space, and I gave the floor back to Maria.
Thank you very much, Carlos and Ariel. Unfortunately, we have no more time for questions, but you can find Ariel around. Now we're going to continue with the closing of LACNIC 43. I'd like to invite Lito Ibarra, who will be announcing LACNIC 44.